Today we're going to talk about section 10.4, the perimeters and areas of similar figures. And hopefully you remember anytime you see the word similar, we're talking about ratios or proportions of side lengths. And we're going to talk about the relationship between the scale factor, the perimeter ratios, and the area ratios. So we're going to start with this rule that happens every time. So if we start with the scale factor is A to B, I know that the ratio of the perimeters are always going to be A to B, or exactly the same. But the area ratio is going to be different. It's not A to B, it's going to be A squared to B squared. So you're always using the scale factor to find the area ratio. So let's fill in the chart. If the scale factor is 1 to 2, we know the perimeter ratio is 1 to 2, and then we'll square it. So we know that the area ratio is 1 to 4. If they give you the perimeter ratio to start, well, perimeter and scale factor are the same. But now we've got to square it to get the area, so 16 to 9 will be the area ratio. Moving on with C and D, we can just fill those in, 4 to 5, square it, 16 to 25. Likewise, 1 to 7 is the same, but square it, 1 to 49. The last one, though, we start with the area. We got to work backwards to get our perimeter and our scale factor. So to get rid of a square, we have to square root that. So our scale factor is going to be 5 to 2, same with the perimeter ratio, 5 to 2. So you need to be able to write that before we put it into some geometry problems. So it says the rectangles are similar and they give you the side lengths of 6 to 8. So it says what is the ratio of the smaller to the larger of the perimeters. I always write scale factor like SF, perimeter ratio is PR, and area ratio is AR. And I'll be setting that up throughout the entire presentation. So remember, scale factor is the side length, but you have to simplify that. That's why the scale factor is going to be 3 to 4. So if we want the ratio of the perimeters, it's going to be 3 to 4. And then, so I'll fill that in here. If we want the areas, we're going to go ahead and square that to get 9 to 16. And you don't have to simplify that there. They just want the ratio of the areas. So let's go ahead and put this into solving some proportions. It says find the value of x and y when the smaller triangle shown here has an area of 3. Well, we can find the area of this triangle since they don't give it to us because we know the area formula is 1/2 base times height. So let's go ahead and find the area. The area is 1/2 the base 12 times the height 8, so you should get the area as 48. And they already give us the area of the smaller one is 3. So let's set up our scale factor equals, perimeter ratio equals, and area ratio equals. Well, they give us the areas to start, so I'm going to start down here where the area ratio is 3 to 48. So we need to work backwards to find scale factor because x and y are sides. But when we take the square root of 3 and the square root of 48, those aren't going to be whole numbers. So what I have you guys do is actually simplify that ratio first to see what it is simplified. So 3 over 48 actually simplifies to 1 to 16. So now looking at those numbers, if we take the square root of both of these, the scale factor is going to be 1 to 4, perimeter ratio 1 to 4. So if we are going to find the side lengths, we need to use the scale factor for our proportion. So if I know the scale factor is 1 to 4, from the smaller to the larger, I know that x over 8 is going to equal that. So then when you cross multiply, you get 4x equals 8. So the side length x should equal 2. Do the same thing for y. 1 over 4 equals y over 12. So 12 equals 4y. When you cross multiply, y should equal 3. Okay, so you have to use the scale factor, not the area ratio when you're finding the side lengths. Let's try another. In this one, it gives us that the area of the larger rhombus is 500, and you're trying to find the area of the smaller one. So I just always label inside. I know the area of the smaller one's x, because that's what we want to find, and the area of the larger one's 500. They also give us our side lengths, so when they give you the side lengths, they're giving you that scale factor to start with. So let's write our SF, ER, and ARs. If you look, all I did was match up the 10 over 25, and then we simplify to 2 over 5. So then the perimeter ratio will be the same, and then I square for the area ratio, 4 to 25. Now, since we're trying to find the area, Which one of the three do you think we're going to use? Hopefully you decided that you know you have to use the area ratio to find the area of the smaller. So I'm going to write 4 to 25 should equal, since 4 matches with this, x goes on the top. Since 4 came from my 10 when I squared the 2. So x over 500. So then you cross multiply, do your math, and you should get the area of the smaller shape to be 80. So go ahead and pause and see if you can answer the second one below. It is a multiple choice. Okay. All right. So when you set up your scale factor, you should get 7 over 10. That means your area ratio is 49 to 100. It is once the area of the larger for this one, and they give you the area of the smaller is 127.3. So your proportion should have been 49 over 100 equals 49 is the smaller, so 127.3 goes on top and x goes on bottom. So when you cross multiply, you should have gotten the answer to be C. All right, here's a slightly different one, but it's the same idea. It says it takes 12 hours to paint a 10 by 18 foot mural. So we're painting, okay, 10 by 18, and this takes 12 hours. There's another wall that is 15 by 27, and you're trying to find how many hours it takes you to paint that wall. So first off, we need to do scale factor. So I'm going to match up 10 to 15, small of small, and then when you simplify 10 over 15, you get the scale factor to be 2/3. So that means my perimeter ratio is 2/3, and our area ratio, we need to square it, is 4 over 9. So if we are painting something, we are covering the area. So we're going to use area ratio in our proportions. We're going to use 4 over 9, and we know that 12 matches with the 4 over x, and we're going to go ahead and cross multiply. When you cross multiply, you should get the answer to be 27. All right, so this one does not have a picture, but it tells us that there are 2 trapezoids, one with a base of 8 feet and one with a base of 13. And then it also gives us the area of the smaller one and one's the area of the larger. So I went ahead and drew it out just to have what it actually gives us in words in a diagram. So just like we've been doing, scale factor is 8 to 13, and that actually can't simplify. So our perimeter ratio is 8 to 13, and our area ratio then is 64 to 169 when we square it. And once the area of the trapezoids, we're going to use the area ratio. 64 over 240 should equal 64 over 169 equals 240 over x. So go ahead and do your algebra and cross multiply. You should get the area of the other trapezoid, the larger one, is 633.75 feet squared. All right, last problem gives us the areas of 2 similar figures. It doesn't tell us what type, but they actually give us the areas, so they're starting with the area ratio. Okay, so they give us that the area ratio is 32 over 50. It wants to know what is the scale factor and what is the ratio of the perimeters. So when you look at these 2 numbers, hopefully you see that they're not perfect squares. So let's go ahead and simplify 32 over 50 into a fraction, and you get 16 over 25. So now looking at those, when you take the square root of 16 and 25, you get 4 to 5 and 4 to 5. So all we are doing is working backwards from the area ratio. And hopefully those are the right answers, and they are. You can also write them with the 2 dots if you want. I just tend to write mine in fraction. All right, that's the end of the video. Thanks for watching.